All right, distance formula day number 1. So distance, remember distance is just how far apart two things are, right? The length between two things, two objects. Okay. Today we're going to be learning how, or starting the process of learning how to figure out the distance between two coordinate points. Okay. So for example, if I have like x, y, like 5, 6, and 10, -5, I can find the distance between those, like from a coordinate plane, okay, by using this formula. So distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now today, all we're doing is just plugging it into the formula. Okay? We're not actually solving. So today's pretty simple. It's just plugging it in. Tomorrow we'll actually start the solving process. So let's start out by just writing distance is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. This is just the distance formula, nothing fancy. All right, so once we have the formula written out, I need to label my 2 points. So I'm going to label these x1, y1, x2, and y2. So remember, every single coordinate point has an x and a y. So I got to keep my ones together. x1 and y1 go together, x2 and y2 go together. Now I could switch it. I could call this one x2 and y2, and this one x1 and y1. It doesn't matter like which one's the ones, which one's the twos. What matters is that you have an x and a y on each one, and the ones are together, the twos are together. Okay. Now all we simply do is just plug it in. Distance is equal to, when I look at the x2, because right here I'm just going to plug in x2, I go up here, my x2 is 10. So that's going to be 10. Bring that minus down, minus. Now I got to plug in for the x1. And go up here, my x1 was -5. So 10 minus -5, bring the square down, plus. Make sure you keep the square root over the whole thing. y2, go up here, y2 is -4. Bring that minus down. And then plug in for y1, and y1 we said was 5 squared. Okay. So we plugged it in. Now the last thing we're going to do today is just simplify if we have two negatives next to each other. When you multiply two negatives, what do you get? Positive. -1, for example, times -1 is +1, right? -5 times -10 is +50. Okay. So if I have these two negatives that are right next to each other, they're multiplying. And two negatives, we said, make a positive. If you don't have two negatives side by side, you would have just stopped with this step today. But since we have the two negatives, we just have to rewrite it. Distance is equal to 10 plus 5 squared plus -4 minus 5 squared. Those two negatives become positive, so we just bring it down. And that's it. So on example 2, once again, just going to write out the formula. Distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay. So now we need to label these again. What am I going to label the -9, 0? X1 and x1 and y1. What's the 3, 4 going to be? x2, y2. All right, let's plug in for it. Remember, bring that radical down to every step you do with these, okay? Don't leave the radical out or you'll get it wrong. All right, Roman, what's the x2?
3.
3. Then minus. Brady, what's x1?
The x1 is
-9 squared. Plus. Angie, what's the y2? Say 4. Yep, 4 minus, Jules, what's the y1? 0 squared. Mandy, do I have any two negatives that are next to each other that need to become a positive? Okay, in that first one there, we have these two negatives and they become a positive. So I just rewrite it now. 3 plus 9 squared plus 4 minus 0 squared. And that's it for today. All right, so example 4. Like I said, we're just going to skip example 3, jump straight into 4. So it says plug into the distance formula, and it says points A and B. So do we care about point C? No. So just mark that one out. It's just an extra point. So they want to know, they want us to plug into the distance formula from those 2 points A and B. Now, it wasn't like they didn't give us what the points were, but can we find what the coordinate points are with the plane, with the graph? Yes. So let's go to B. Remember, X runs left and right. It's a horizontal. Where's the B on that X axis? 1. If I just go straight down, it would go to 1, right? So it's going to be 1. And then what's the Y on that one?
Not negative, +3.
Positive 3, because the Y is the vertical axis, so it's the 3, positive 3. Okay. Now A, what's the X on it?
-3.
Negative 3. We just go straight down to where it crosses the X axis, and it's negative 3. And then what about the Y? 2. Okay. So on these, I think on your homework they have a line on it, but you just go to the end of the line, just whatever the points are on the end of the line, and figure out what's their coordinate points, find them, and then just work it like the first ones we did. So let's label these. One of them's going to be x1 and y1. One's going to be x2 and y2. Remember, it doesn't matter which one you label 1 and 2. I could have called the negative 3, 2, x2, y2, but the other one would have just become x1 and y1. You can have them switched, and it's totally fine. It'll still work out the same. So my distance formula, it's going to be x2 minus x1 squared plus y2 minus y1 squared. Now let's just plug into it. Angel, what's my x2 here? 1. Minus Mateo, what's my x1? Negative 3, so 1 minus a negative 3 squared. Then Paula, what's my y2? 3. Minus Luis, what's my y1? 2 squared. Class, do we have anything that needs to be simplified? Any negatives to become positive? Yeah, we got 1 right there, right? So we just rewrite it, and that'll be our answer. 1 becomes 1 plus 3 squared plus 3 minus 2 squared. And that's it.